This is Euclid Book 10, proposition number 45. Here's the diagram. Now, you say, well, where do we get this? And where do we get this? And where do we get this? Okay. When it comes to AC, that's this length right here. Okay? And what we did was we made a square, and every one of these sides is going to be the length of AC. Same thing right here. Every one of these four sides are going to be the length of CB. Okay? Now then, what about this rectangle? Well, two sides are going to be the length of AC. Okay? And two sides are going to be the length of CB. That's where we get all that from. Okay. Now then. A major straight line is divided at one and the same point only. Let AB be a major straight line divided at C so that AC, CB are incommensurable in square, and make the sum of the squares on AC, CB rational, but the rectangle AC, CB medial. Okay. What does that mean? Well, first of all, the line AC and the line CB, they are incommensurable in square. Okay. Secondly, now then, let me make sure of this. Okay. If you add these two areas together, they're going to be rational. But this area is going to be medial. These two are rational together. This one's medial. Okay. I say that AB is not so divided at another point. For if possible, let it be divided at D also, so that AD, DB are also incommensurable in square, and make the sum of the squares on AD, DB rational, but the rectangle contained by them medial. Well, we got all of this stuff from up here. Okay? AD is incommensurable in square with DB. Okay? And if you add these two areas together, they're going to be rational. But this area is going to be medial. Okay? Got that so far? Good. Then, since that by which the squares on ACCB differ from the squares on ADDB is also that by which twice the rectangle ADDB differs from twice the rectangle ACCB. So in other words, if you add these two areas together, and you add these two areas together, one of these sets, this is one set here, this is one set here. One of these sets is going to be bigger than the other. Okay? Now, however much one of these sets is bigger than the other, then twice the area of this is going to be one of these is going to be bigger than the other. And actually, it's twice of one area is going to be bigger than twice of the other. That's what he's saying. Okay, let's go on. While the squares on ACCB exceed the squares on ADDB by a rational area, for both are rational. Okay, so now we're going to say that this set is bigger than this set by a rational area. And that's because this is rational, this is rational. Okay? Therefore, twice the rectangle ADDB also exceeds twice the rectangle ACCB by a rational area, though they are medial, which is impossible. And this is by Euclid Book 10, proposition number 26. Therefore, a major straight line is not divided at different points, therefore it is only divided at one and the same point. Now, okay, what they're saying here, hang on, What they're saying here is that twice this area is bigger than twice this area by a rational area. But the problem is that these two areas are medial. So how can the difference between this and this be a rational area? It can't. So therefore, this line can only be divided at one point. And that is the whole proof. I will tell you more in a future video. Stay tuned.